Good afternoon, good morning, everyone. Welcome to our fourth GTT webinar in 2022 with our very special guest, PONANT and GASUM. We're gathering today to share with you the key takeaways of what makes a successful LNG bunkering operation. Just some housekeeping words before we get started with the webinar. So the webinar is recorded and the recording will be available at the end. We will have a Q&A session, so please do not hesitate to ask any questions you may have during the presentation and using the Q&A module at the bottom of your screen. And we will do our best to answer your questions at the end. What you're going to see here is the return of experience of several bunkerings along all the phases of the project and skill up during operations between PONANT, GASUM, and GTT. If you are a ship owner, you will see how you can be assisted throughout your project from concept design to the first bunkering operations. We hope you will understand that greener shipping is possible right now using LNG as a fuel, which is safe and predictable. Let's first have a short focus at the different speakers we have today. So my name is Jean-Benoît Bensoussan, and I'm a business development manager at GTT with a specific focus on LNG as a fuel applied to cruise vessel applications. From GASUM, we have Grégoire Artigue, sales manager for marine LNG and LPG at GASUM. Grégoire is working on the structure and development of LNG bunker markets and infrastructure, making LNG widely available to LNG as fuel customers. From GASUM, we also have Martin Cato, technical sales manager. Martin has an extensive technical experience of LNG handling from terminal to LNG carriers through LNG as a fuel bunkering operations. From PONANT, we have Sébastien Louis, project manager, LNG project manager since 2018, working on the implementation of the installation of the LNG system on board PONANT cruise vessel, Le Commandant Charcot. Sébastien has been following every steps of the development of Le Commandant Charcot from first drawing to first commercial cruise. A warm welcome to the three of you. So we've made it. In September 2021, Keros, owned by GASUM, delivered a full LNG bunker to Le Commandant Charcot, the flagship of PONANT fleet, first hybrid electric polar exploration ship powered by LNG. Can you imagine? It is more than 3,000 cubic meters of LNG transferred in 10 hours during a commercial operation. As makers, experts, and operators, we would like to bring you some feedbacks at each steps of the development of the project. This overall look back will be split in 6 parts. First, we will see how the ship was specified and concept defined. Then we will have a focus on risk assessment and simulations during the engineering phase. Sébastien will talk about the importance of LNG training. And eventually, we'll try to understand how the first LNG operations were prepared and performed, and in particular, how far can reality be predicted. The first key to a successful LNG fuel project is a proper specification of the vessel and its LNG fuel gas system. Sébastien, what can you tell us about the Commandant Charcot early design conception phase?
Thank you very much, Jean-Benoît. Good morning, good afternoon, everyone. So I will present you some of the main characteristics of Le Commandant Charcot vessel that has been delivered last year in July 2021. So basically, it took 6 years from the concept of this vessel to the reality. Le Commandant Charcot is a luxury polar expedition cruise vessel of 150 meter length and can accommodate up to 270 passengers and 190 crew. The ship is classified as a Polar Class 2 vessel because it needs to sail in ice and operate in a very remote area, such as the water or North and South Pole. The Polar Class 2 means that the vessel can break 2 meters of ice at 2 knots. This vessel has also been designed as a ship of opportunity for the scientific community. The ship is indeed fitted with some labs to allow the researchers to embark on board and realize some measurement campaigns in order to study water, air, and biodiversity in the extreme polar regions where some data are often not available. So you will understand that operating in such a fragile ecosystem, the choice of LNG as a fuel was kind of obvious for this vessel and was present at the beginning of the project in order to reduce, minimize on our environmental impact, both in terms of pollutants such as SOx, NOx, and particulate matter, but also in terms of greenhouse gases reduction. In order to make all of our trips to the North and South Pole, the ship needed about 4 weeks of LNG autonomy in polar conditions. And this was made possible by the integration of 2 LNG tanks, 2 GTT Mark III LNG tanks for a total capacity of 4,500 cubic. And I will let the floor to Jean-Benoît to tell you more about the design of these very specific LNG tanks.
Thank you, Sébastien. Yes, as you just mentioned, the autonomy of the ship was one of the constraints in the design of the overall project. GTT Mark III technology allows to build LNG tanks with some kind of exotic shape to maximize the volume of LNG loaded on board. You can see here on the left picture, the aft tank following the shape of the ship hull lines. The Mark III technology enables to reach a low boil-off rate in order to keep the LNG cold long enough during the vessel positioning phase, also called transit period, between different cruise locations. In order to offer the maximum autonomy and flexibility, GTT designed an LNG tank with a 2-bar gauge design pressure. This was achieved thanks to an alternative design process run between PONANT, the French Classification Society Bureau Veritas, and the French flag. The 2-bar gauge tank design allows to increase the holding time. As you can see on the left-hand side graph, where the red curve shows the holding time in an atmospheric pressure tank, whereas the blue curve shows the holding time for a 2-bar gauge tank configuration. This 2-bar gauge option also allows to bunker warmer LNG, thus offering more flexibility in the quality of LNG bunker. I must also add that an approval in principle has been delivered by DNV on this 2-bar gauge tank concept. So we've just seen several items which must be properly investigated and decided before the order. Then, after the project is launched, the LNG fuel propulsion requires specific engineering following the IGF code and class rules, as well as recommendations from the SGMF. Even if a general risk assessment is a regulatory requirement for the vessel design and for the operation, it is highly recommended to have a dedicated risk assessment as well as simulations for the bunkering operation itself. In the next slides, we try to highlight the results and improvements coming from the work carried out between PONANT, GASUM, and the port authorities where the first bunkerings were performed. So Sébastien, what are the main aspects covered during such a risk assessment?
To tell you how we prepare for this first operation, actually, this began for us in early 2018. So it's more than 3 years before the delivery of the vessel. So at this time, we performed the first risk analysis with the Green Zeebrugge, bunker vessel. And then it was followed with specific compatibility studies with various LNG bunker vessels. What you can see on these slides is some key outcomes of the risk analysis. It includes mooring analysis with the definition of the mooring arrangement, the definition of the safety zones that are the result of the simulation of gas leaks around the ship, and also the definition of the hose connection system. One of the interesting outcomes of the risk assessment with GASUM was to configure the hose system with the emergency release coupling, as you see on the right of the slide, which is on the client side, but is also outside of the bunker station. I would like to ask Grégoire if you could tell us more about this process from the LNG supplier and also the different steps to get a permit to bunker LNG in a port.
Yes, thank you, Sébastien. I'm very happy to participate and give also our insight from a supplier's perspective in how to approach such bunkering operations. We had several levels of discussion, stages of discussion with PONANT and the yard that built the vessel over the years. But we had also, as Sébastien pointed out, the very early initial discussions about the mooring and the risk zones and the way that the bunkering operation would most efficiently be conducted. And especially in those days, in early 2018, when there were little LNG fueled vessels up and running and also not many bunker vessels actually operating, it was quite important that the supplier and the customer, the company building the vessel, get in touch quite early in order to make sure that we identify any shortcomings or any issues that might appear. And as Sébastien pointed out, we actually managed to identify 2 issues, one of which is this hose, which the tail of which was extended, so it would remain outside of the hull of the Commandant Charcot. But we also suggested to PONANT, and it was early enough in the stage so that it could be still implemented during the construction phase, to add an additional pollard to the Commandant Charcot in order to increase the flexibility of the Commandant Charcot when it comes to accepting and mooring different types of LNG bunker vessels. The discussion with PONANT blended then in a discussion with PONANT and the yard in order to prepare the first bunker operation. And for that, one of the steps is clearly to obtain the relevant permits. GASUM obtaining permits and obtaining the relevant permits and then preparing bunker operations with mooring analysis and risk analysis is something that GASUM does every day. But still, it needs to follow a certain process. The capacity to offer different ports as a potential supply port for a customer like PONANT that operates all over the world is an important tool to increase the operational flexibility of the vessel, but also making sure that it is compatible with not just one LNG bunker vessel, but several out of the fleet that GASUM operates. During the course of a discussion or our preparation of the bunkerings, both with PONANT and with the yard Langston, where the Commandant Charcot was finalized, we had to actually apply for several types of permits in order to make sure to be able to deliver. The preparation at the yard for the first bunkering, which was a truck-to-ship bunkering, including a cooling down and a gassing up, we secured the permit with the relevant authority. It was not the port authority, but the national Norwegian authority, the DSB. and made sure that we showed that this operation was safely manageable. We coordinated with the local fire brigade because it's quite a small space there, and we organized 5 training sessions with the staff of the yard in order to make sure that they are familiarized with the processes and manage the ways to manage the deliveries. And finally, we used the checklist of the IAPH both for the truck-to-ship and ship-to-ship deliveries. To implement the ship-to-ship delivery, the truck-to-ship delivery, we used equipment that we provided, reducers, hoses, the flares, and it took us quite some time to deliver the first 2 trucks because we did want to do it safely and not rush into anything and make sure that everything was up and running correctly. Then we switched to the first operation with Corallius, which was the first Type C bunker vessel to membrane tank operation that GASUM performed. So we were quite eager to see how this would unfold. But here again, we managed to do everything according to the plan, and also the fact that we included the staff not only of the yard, which was still in charge of the vessel, but also of Ponant in the preparation and then in the first, I would say, technical LNG delivery, ship-to-ship delivery, because it was designed to test the bunker station, to test the equipment on board. The fact that we involved the staff of Ponant and the crew of Ponant also allowed that to familiarize with the procedure, familiarize with the way it works, and then make sure that it is up and running when the ship is delivered. And securing those permits and making sure that it's not only compatible with the Corallius, but also with the second bunker vessel, Kairos, offered both the security of supply to the yard and to Ponant, but also flexibility in terms of where exactly the vessel could be supplied. The next step, and I would say the big test commercially, and also I think also in terms of publicity, was definitely the delivery of a big volume under commercial conditions in the port of Le Havre. When we delivered those volumes in Le Havre, we had several objectives. One was to put Le Havre on the map of LNG bunkering, because it's the first LNG ship-to-ship bunkering that was ever performed in the port of Le Havre. Show that SIMOP operation, meaning that while we were delivering LNG bunkers to the Commandant Charcot on the port side, other supply activities could be performed. The crew could go up and down of the vessel, and to show that this could be quite safely done, and in the future, hopefully also with passengers going up and down, showing to the port that this is a safe operation and there is no reason why this shouldn't be allowed in the future for deliveries to cruise vessel or for any other vessel. And then the commercial objective of GASUM working with Ponant was to deliver as much LNG as possible in order to allow the Commandant Charcot to go for its first cruise to the Antarctic region and deliver the LNG and use the LNG in those sensitive areas. We approach this bunkering or this permitting process as we do with all our bunkerings, developing a joint plan of operations with the port, with the customer vessel, and with GASUM, identifying the risk, treating the risks, and then setting up the relevant procedures. I must say that we were a bit curious to see how this permitting process would work in Le Havre, because our experience told us that the bigger the ports are, the more complicated it is to get the authorizations. But in this case, the Port of Le Havre has been very supportive and applying the same standards as the Port of Rotterdam, and GASUM being an approved operator in the Port of Rotterdam, it allowed us to actually be quite fast and obtain those permits and authorization to perform the bunkerings. During the bunker operation, as this was the first one, we had also a representative of the Port of Le Havre, which was actually on the Commandant Charcot, looking out and monitoring how things were unfolding. And at the end of the day, I think everything went very smoothly, very efficiently. And the only thing that might have almost challenged that operation was nothing that was linked neither to the port nor to GASUM or PONANT, but it was, I would say, a typically French event where the fishermen of the port were blocking the port for some hours for some protests. But fortunately, we sneaked in the port early enough to perform the operation, and when we had to leave, the port was free again.
Thank you, Gregor, for this and this anecdote and the clarification of the port authorities' involvement. Ship-to-ship transfer between LNG carriers and FSRUs is not new. In addition, GTT can rely on hundreds of successful bunkering from the Clean Jacksonville barge. And just to add up on the experience of GTT in terms of LNG transferring, you can see on the right-hand side a picture of some tests which were conducted on an LNG brick, which helped to calibrate GTT's bunkering simulation models, which we will talk about later. Since 2020, many bunkering operations were carried out involving membrane tank receivers and bunker vessels of both Type C and membrane technology. And what's important to note and remember here is that tank pressure and vapor can be safely and effectively managed from LNG bunker vessels with both Type C to LNG fueled vessel with membrane tanks. So in order to support PONANT in this bunkering operation, GTT performed simulations to validate the feasibility of the operation. So GTT has developed a tool to perform bunkering simulations with any kind of tank technology. So our tool allows to model the bunkering operation during a port call. And it is possible to do first to assess the evolution of pressure on board both vessels, so the bunker vessel and the receiver vessel. And second, predict the LNG bunkering flow rate given a set of process conditions and design of the lines. So in this slide, we would like to show you the bunkering simulation results with and without vapor return. So for this simulation, we've considered a 6,500 cubic meter Type C bunker vessel bunkering le Commandant Charcot with some consumption on the auxiliary engine on both vessels. So you can see that with vapor return, you reach higher flow rate and that than without vapor return. However, without vapor return line connected, the maximum pressure inside the tank remains below the maximum design pressure of 2-bar gauge. So what's important to remember here is that bunkering can be predicted, that the simulations we run are validated in real life operation, and most importantly, that bunkering operation is possible in both cases with and without vapor return. So the studies carried out by GTT have highlighted 4 levels of optimization during bunkering operations. The levers which are relevant for, again, any kind of LNG tanks. So those 4 levers are the vapor return, the gas consumers, the initial conditions of the tank, and the piping design. So vapor return allows to, as we saw in the previous slide, prevent excessive pressure increase in the receiver or LFS tank. It helps increase the flow rate to reduce the time for bunkering and also keep a low rate in the bunker vessel. The gas consumers, either auxiliary engine, boiler, or subcooler, allow an active pressure management on both vessel sides. They also help having a safe operation. The initial conditions of the tanks are key to safe and smooth operation, especially a low saturated pressure on the feeder side and the cooling down on the LFS tank prior to the bunkering operation. This gives pressure margin for the LNG transfer. And finally, the last lever, smart design piping. By design piping, we mean length and diameter, allow to reduce heat ingress, which would generate additional boil-off gas. So you understood it. A good preparation is key to define optimal initial conditions, operating parameters, and consolidate bunkering sequence. This is why I would like to ask you, Sébastien, what can you tell us about the collaboration between PONANT and GASUM?
Yes, thank you, Jean-Benoît. As it was mentioned by Grégoire a little bit earlier, the collaboration with GASUM began during the construction stage of the vessel. It is absolutely key to begin the process with the supplier as soon as possible to anticipate compatibility issues. The collaborative work from the gas trials at the shipyard until the commercial LNG bunkering operation in Le Havre also contributed to a progressive and smooth learning curve for the PONANT officers in charge of the LNG bunkering operation. It was really beneficial for the crew to get used to this new fuel gradually. So during the construction and commissioning phase at the yard, GASUM first delivered liquid nitrogen and LNG by trucks to perform cold tests of the LNG system and the initial cool down of the tanks. Then the first LNG ship-to-ship operation was done in June, so the ship could go for the ice trials during 3 weeks in order to validate the LNG system before the delivery in ice conditions. Once the vessel was delivered to PONANT in July 2021, she was bunkered once more in Norway at the yard. And finally, in September 2021, it was the first LNG bunkering in real commercial condition. By real commercial condition, I mean really in cruise mode, with full staff on board and the CMOPS operation with passengers embarking, disembarking, and loading, unloading operation. So now I would like to ask Grégoire, what can you tell us about this joint achievement with PONANT?
What I can say, I mean, in addition to what I mentioned before, is that that indeed it was very helpful that we started at a very early stage, and that also the discussion was not only bilateral between PONANT and GASUM, but also trilateral with the yard always involved, as it was new to the yard and PONANT. It was very good that we had this discussions in 3 and progressed along the line so that everybody would be comfortable with the decision and the procedures that have been developed at each stage for the truck-to-ship delivery, for the first ship-to-ship delivery, where we needed to verify and check how the boil-off is managed and how the pressure is managed, and then down to the actual first very smooth commercial operation in the Port of Le Havre. And I think it was very good experience to see that we brick by brick build up this confidence and this competence on every side. And when I look at what we achieved in those deliveries and in those operations, I'm wondering, Sébastien, how do you see now a regular bunkering operation unfolding, and in which steps?
Yeah, for us, what it is as a cruise operator, what is very crucial regarding the LNG bunkering operation is that it does not impact the schedule of the vessel. In our case, a complete call at berth lasts 12 hours, so it was absolutely necessary that the LNG bunkering operations fits in this time frame. The other key point was the requirement to perform SIMOPS at the same time of the LNG transfer. And this actually was done successfully in Le Havre port, with people embarking, disembarking on the quayside, with loading and unloading operation on the quayside, while the bunkering operation itself was performed on the opposite side. One other point that is interesting to note when you look at these phases of the bunkering operation is that you have actually an incompressible period before and after the LNG transfer itself. You have connection, inerting and safety tests before the LNG transfer, and after you have also purging, draining phases and the disconnection. So it is something that needs to be taken in account in your planning for this kind of operation.
Yeah, I think that's quite a valid point, Sébastien, that you just raised here. It's that we sometimes operators are tempted to maximize the flow rate in order to reduce the bunker operation. But I think you made quite a good choice in terms of the size of the bunker station and the hoses that we need. Because if you do maximize the flow rates, you need bigger equipment, you need bigger hoses, bigger breakaways, bigger QC/DC couplings, and those take longer than to install. They take longer in order to get to be handled by the crew. You need then cranes to do that. So there is an equilibrium to find, and I think in terms of the volumes needed and the flow rate that the Commandant Charcot can take, you found quite a good equilibrium there.
Thank you, Grégoire. So bunkering will be performed by the crew. So the crew requires a dedicated training, but actually the training is necessary at several steps of the project. And LNG as a fuel can lead to several changes within the company, especially when it's new. So, Sébastien, how has LNG impacted PONANT organization?
Yeah, actually, as you said, Jean-Benoît, it's not only the crew, but it's also the organization within PONANT that is impacted with the change to a new technology like LNG. First of all, for the offshore case for the crew, actually we had to build a complete new training program. One of the challenges that we had with this project is that LNG was the big thing, but not the only new thing on board. Our crew needed also to be trained on ice sailing, high tension, battery handling, azipod operation. So a lot of stuff for one vessel. If I just come back to LNG, so our approach has been actually twofold. Onshore, it was very important to implement gas culture and raise awareness of LNG inside PONANT organization. As you can see on the right figure, switching to LNG as a fuel has an impact on every department within PONANT. Among them, the crew scheduling, the sustainability and CSR, the purchasing department, legal operation, the safety and security department, the strategy, the communication. So it really impacts all your organization, and all of these people need to be aware of the implication of using this new fuel. And the second point regarding the crew, so we basically came with a simple fact, is that the regulatory training was not enough. So in addition to STCW basic and vest training, PONANT has developed a ship-specific training that included, first of all, in-house e-learning familiarization for all the crew regarding LNG awareness and polar code familiarization. Then there was the use of a simulator developed by GTT for engine officer, so they can simulate the real operation of the specific installation of the ship. And the third one was a training course on the Wärtsilä 31 dual fuel engines from the manufacturer Wärtsilä. And finally, the third pillars was to actually make the crew gaining some practical experience on LNG operation. So that's why we send engine officers to spend some time on board IGF vessel and LNG carriers vessels.
Well, finally, we get to the end of the new building, but the beginning of the ship operation. In the next slides, we will see some figures on key parameters of the first bunkerings.
Yeah, so far, 3 ship-to-ship LNG bunkering operations were performed, and you can see the details on the slides. I will not spend so much time on the table, but I will try to give some of the main takeaways that we got from this 3 bunkering operation. First of all, we saw that the operation can last 10 hours when it is optimized. So it fits our time frame and our schedule. We have also seen that the 2-bar gauge design is adding flexibility in a specific situation. For example, during the bunkering 1, when a partial cooldown was necessary, and then it was followed by a bunkering operation. We can see that we reach 0.8 bar gauge. And apart from this bunkering number 1 that was kind of special, when you look at bunkering 2 and 3 that were performed with 2 different Type C bunker vessels, you can see that they were performed without vapor return to the bunker vessel, which was something that actually we did not expect at the beginning. And finally, one of the main takeaways is that we have performed these 3 bunkering operations with 2 different Type C bunker vessels. So it's safe to say that bunkering from Type C to membrane is not a problem at all. Maybe Jean-Benoît, you could explain how the operation went during the bunkering in Le Havre with Keros bunker vessel.
Absolutely. Thank you, Sébastien. And I think the main message needs to be repeated, but there is no issue bunkering from Type C to a membrane tank. And as you can see here on this graph, you have the pressure evolution in red in the 2 tanks of Le Commandant Charcot, the LNG volume loading, and the auxiliary engine consumption in yellow at the bottom of the graph. So the tank pressure inside the Commandant Charcot remains below 0.7 bar during the whole operation, which corroborates the simulations conducted by GTT. So some key takeaways of the presentation we just had. The LNG journey is possible thanks to reliable partners. GASUM and PONANT worked closely together towards safe and efficient operation. Operation in LNG can be predicted with a high degree of accuracy. GDT two-bar gauge tank is a key enabler for passenger ship successful LNG operations. And finally, digital tools allow to collect and then post-treat operational data and enable predictability of LNG behavior when sailing. So we've come to the end of our presentation. We hope that you have found it interesting. So questions raised during the event, which are not answered live, will be passed to the speakers after the event. And if you have questions after the webinar, please use the email address available in the invitation we have sent you to contact us. So I see here in the first question, how did you manage tank pressure while not having a bug return line? Maybe Sebastian, do you want to jump in and answer this this first question?
Yes, thank you, Jean-Benoît. Thank you for the question. Basically, the vapor line was connected for safety, but there was no vapor return to the bunker vessel. We managed the pressure by pressure increase inside the tanks for one point, and the second point is that we consumed also some bug on board. So the conjunction of these two factors, we managed to perform the operation without vapor return. Maybe a third point is also that the LNG delivered was also very cold, so it helped also to have a perfect balance between pressure increase, bug consumption, and it allowed us to perform this operation without vapor return.
Great, thank you, Sebastian. I have a question. Are LFS membrane tanks safe from the effect of slushing? What are the reasons for this? I think I can take this one. So LNG as a fuel membrane tanks equipped with the Mark III technology are designed for partial fillings, contrary to LNG carriers membrane. And to make sure that the membrane withstands the slushing loads, we use reinforced polyurethane foam with a higher foam density. And in case this is not enough to just increase the foam density, we can also use what we call wedges, which are pieces of wood or aluminum, which comes under the corrugation of the membrane. Maybe another question for you, Sebastian. How do you manage passengers' awareness about LNG bunkering in order to make sure that they feel comfortable when the operation is taking place?
Well, there are several things. First of all, when the passengers are embarking and there is a bunkering operation planned during that journey, they are informed during the first meeting where the captain is explaining how the cruise will go. There is a briefing about that. Then there is some announcement just before the LNG bunkering operation takes place, explaining where are the areas that are forbidden, and also that the access to the balcony for the people that are on the bunkering side will be not possible.
Thank you, Sébastien. Maybe one question for Sébastien and Grégoire. Now that you have successfully completed several bunkering operations, what is the next focus of your collaboration between PONANT and GASUM?
Sébastien, well, I can start. I think we have like several items we can work on. I mean, one is to improve the efficiency of the operations. As Sébastien was pointing out, it is very crucial that they are as short as possible in order not to impact the schedule of the cruise vessel. I think one other topic that we can work on is definitely to decarbonize, working on decarbonizing options. I mean, GASUM has several. I mean, has the possibility to deliver, for instance, bio LNG in order to abide by those obligations or those aims. And there is also certainly the extension of the, I would say, the network of the LNG bunkering ports where PONANT can get LNG for the Commandant Charcot, giving the wide range of geographies that is covered by this vessel. I don't know if you have anything more, Sébastien.
I think you have covered all the points, Grégoire. Thank you. I have nothing to add to that.
Thank you. I have another question, quite technical question. Why is there a 70-meter safety zone aft of the cruise ship, but only 10-meter safety zone at the forward end?
Yeah, maybe Jean-Benoît, you could go back to the slide when we see the safety zone, if you can.
Sorry, here it is.
Yeah, so basically the safety zone is based on the leak scenarios. The leak scenarios that we took into account here were actually two scenarios: leakage from the bunkering vessel manifold. This will bring you the flammable gas cloud that can reach up to 22 meters height. And regarding the aft part, it was caused by the second scenario that we considered, which was the LNG contained in the hose was spreading into the water in case the valve of the emergency recoupling was failing. So it was we took voluntarily some quite conservative scenarios to be on the safe side, knowing that this is also a passenger vessel.
Perfect. Thank you very much, Sébastien. Grégoire, you already talked about it, but maybe you could tell us a little bit more about how easily can you plan for bunkering in new harbor, in new ports, now that you have performed those with PONANT?
Well, I wouldn't say easily, but it's doable, and it depends a lot on the lead time that we have to prepare, and it depends a lot on the port. So some ports are very easy, and it is quite smooth to obtain the relevant authorization, and some other ports require much more work and much more preparation. It depends also on the type of vessel. If you have a cruise vessel, obviously with passengers on board, then the regulations and the restrictions are higher, and the safety expectations are higher than if you have, for instance, a container ship delivering LNG to a container ship. But also the operational risk is then a bit different when you have sim-op operations, moving containers, as opposed to a cruise vessel where you have only passengers embarking and disembarking. So I would say it depends really on the specific case. The more time we have to prepare, the better, and the more certain is the result. But I would say that we haven't had any no from any port so far, apart from the port of Hamburg, where it's still quite difficult to get any approval.
Thank you. Thank you very much, Grégoire. I have another one coming. What is the difference, if any, between Coralius and Chaos in terms of bunkering operations? Grégoire, I think this one is for you.
Well, as far as I understand, not many. I mean, Kairos is a bit bigger and has a slightly different setup. But in terms of vapor management, both operations went very well. Most of the LNG, the gas produced, the vapor produced was burned in the engines, as you pointed out, Jean-Benoit. So for me, I don't see any big difference other than Kairos is has a bit stronger pumps and can deliver quicker to the bunker vessel. Sebastian, have you witnessed any differences?
Not really. As you said, I think we reached maybe a little bit more flow rate with Kairos because of the pump capacity, but otherwise, during the two bunkering without evaporator, the vapor was managed in the same way. So on this aspect, no real big difference.
Perfect. Well, thank you very much to all of you. Thank you to all the participants and for a very interesting question. Thank you to you, Sébastien, Grégoire, and Martin, for taking part in this webinar. Finally, if you enjoyed this webinar and you'd like to learn more about other solutions, you're free to register and join us for the next webinars. It is indeed a very busy week for GTT regarding webinars, as we will host another one tomorrow on a design of LNG-fueled pure car and truck carrier fitted with a membrane tank, taking full advantage of Mark III modularity. The link to register to this webinar is in the chat box. So now it's time to end this webinar. Many thanks for attending. Have a good day or a good evening, depending on where you are in the world, and see you next time. Thank you very much, and bye-bye.